The rapid technological changes have radically changed the way businesses are producing, processing, analyzing, and consuming data. Today, organizations are generating huge amounts of data at very high speed and from various sources, what we now call as big data. This big data has fueled the need for huge data sources and efficient processing technologies to handle, process, and analyze big data. This has also triggered the development of several innovative technological frameworks that make big data solutions possible. Distributed computing, parallel computing, and in-memory computing are a few such big data-related technologies. These technologies are designed to handle the various characteristics of big data: volume, velocity, variety, and veracity. In this video, we will discuss about the Hadoop distributed computing environment and how each of its tools cater to the storage and processing aspects of big data. By the end of the video, you should be able to give a broad overview of the Hadoop distributed computing environment. Before we go into the details of the Hadoop distributed computing environment, let us first understand the concept of distributed computing and how it relates to big data. A distributed computing system is a collection of computing resources, such as computers, that are interconnected. Each of these computing resources, usually called as node, has its own memory. It can process information and also exchange information between the connected resources. So, how does distributed computing work? In a distributed computing environment, different parts of a program are run simultaneously on two or more computers that are communicating with each other over a network. This virtualization feature of distributed computing environment provides the following key benefits: flexibility, economics of speed, reliability, performance, scalability. Hadoop is a popular open-source platform that is based on distributed computing environment. Let us now discuss the Hadoop distributed computing environment in detail. Hadoop is a software framework that supports the processing of large data sets in a distributed computing environment. In Hadoop, a computing application is broken down into several small parts or tasks that can be run on any node or computer in the network. Thus, Hadoop makes it possible to run applications on thousands of commodity servers involving thousands of terabytes of data. Its distributed file system facilitates rapid data transfer rates among nodes and servers and allows the system to continue operating uninterrupted in case of a node or server failure. This ensures fault tolerance and robust framework for handling big data. Data replication or automation within the Hadoop cloud computing system ensures customers get uninterrupted service. It guarantees that if a node fails, other parts can take over to continue service. We can thus conclude that the Hadoop distributed computing environment is the most pragmatic way of managing huge volumes of data and also process the data in parallel easily. It is a reliable, high-bandwidth, low-cost data storage cluster that facilitates the management of related files across machines. But what are the multiple computing resources that Hadoop uses to execute a task? Hadoop is an open-source, Java-based programming framework source. It is part of the Apache project sponsored by the Apache Software Foundation. It is used for implementing large-scale distributed batch processing infrastructure. It allows the developer to write and test distributed systems and also automatic distribution of data and processing work across machines. The core of the Apache Hadoop consists of two parts, a storage part and a processing part. Hadoop Distributed File System, HDFS, provides the basic structure and service needed to support the core requirement of storage for big data. MapReduce is the part that is used for retrieving, computing, sorting, counting, and filtering data. It is used for parallel or distributed data processing with execution control. While HDFS and MapReduce provide the basic structure and services needed to support the core requirements of big data solutions, the other tools and technologies of the Hadoop ecosystem provide the components needed to build and manage purpose-driven big data applications for the real world. Let us take a look at these tools and technologies of the Hadoop ecosystem. One of the databases in the Hadoop ecosystem is HBase. It is a distributed, columnar database that utilizes HDFS as its persistence store. It enables all data to be stored into tables, thereby leveraging structured data for random access. Then there is a batch-oriented data warehousing layer built on the core elements of Hadoop, known as Hive. It enables bulk handling of structured data. Pig is an interactive or script-based execution environment supporting Pig Latin, a language used to express data flows. It was designed to make Hadoop more approachable and usable by developers without Java programming background. The Pig execution environment has a Hadoop mode, also called MapReduce mode, where all scripts are run on a given Hadoop cluster. Scoop, SQL to Hadoop, is a tool that offers the capability to extract data from non-Hadoop data stores like MySQL, transform the data into a form usable by HDFS, and then load the data into HDFS. Apache Flume is a distributed system that is used to transfer large amounts of data stored across different sources to a single centralized database. Flume is a reliable system and able to efficiently collect, assemble, and move data. Mbari is a web-based tool for provisioning, managing, and monitoring Apache Hadoop clusters. It also supports Hadoop HDFS, Hadoop MapReduce, Hive, HCatalog, HBase, Zookeeper, Oozie, Pig and Scoop, and Yarn. Mbari also provides a dashboard for viewing cluster health. That was about the tools and technologies that are available with Hadoop ecosystem. Apart from Apache Hadoop that is discussed above, there are several other commercial distribution versions of Hadoop. Each of these offers unique features to address big data challenges. Together, these complete the ecosystem. Cloudera, Hortonworks, Intel, Greenplum, MapR, and AWS EMR are part of the Hadoop commercial distributions. We will discuss a few popular distribution versions. Apache Hadoop is used for implementing a large-scale distributed batch processing infrastructure. It allows the developer to write and test distributed systems and also automatic distribution of data and processing work across machines. Cloudera offers industry's best technical support to Apache Hadoop, providing speed, scale, and centralized management of data. Hortonworks Data Platform is a complete solution, offering not just data processing and management, but the enterprise capabilities to match the demands of an enterprise spanning security, governance, and operations. All of this is delivered in 100% open source. MapR's Apache Hadoop distribution claims to provide full data protection, no single points of failure, improved performance, and dramatic ease of use advantages. Now that you know about the Hadoop distributed computing environment, let's see how much you recall. If you selected columnar database, you are right. HBase is a distributed columnar database that utilizes HDFS as its persistence store. Let's do a quick recap of what you've learned in this session. A distributed computing system is a collection of interconnected computing resources called nodes. Hadoop is a popular open-source platform that is based on distributed computing environment. Hadoop is a reliable, high-bandwidth, low-cost data storage cluster that facilitates the management of related files across machines. The core of the Apache Hadoop consists of two parts, a storage part and a processing part. Hadoop Distributed File System, HDFS, provides the basic structure and service needed to support the core requirement of storage for big data. MapReduce is the part that is used for retrieving, computing, sorting, counting, and filtering data. The other tools and technologies of the Hadoop ecosystem that provide the components needed to build and manage purpose-driven big data applications for the real world are HBase, Hive, Oozie, Pig, Scoop, and Flume. Cloudera, Hortonworks, Intel, Greenplum, MapR, and AWS EMR are part of the Hadoop commercial distributions.